Oh, good morning. Some of y'all probably still in bed. This is Basics 2 practice. It's got some ACT stuff on it too, because, that's important. It's got one new style question on it. The rest of it's the same as the last one. It's kind of a slow building process. Anyways, I did grade your last ones before I started recording this video, and we had some kids missing the first one. You're not supposed to miss the first one. You add 8 to both sides, kids. So 5x is now 5. You divide through by 5 and x is 1. You're not supposed to miss the first one. There's at least 2 ways to do the second one. I'll show you both. Because this 12 is divisible by 2, and you can't always do this. I mean, it's if the opportunity arises. You can divide that 2 out. And again, that's because the opportunity arose. You can't always do that. Of course, then we add 8 to both sides. And 6 and 8 makes 14, so x is 14 thirds. The safer bet, and I guarantee you when you had Buckley, she always taught you the safer route, not necessarily the shortest route. But the safer route is to distribute. 2 times 3x is 6x, 2 times negative 8 is 16. And then we'll add 16 to both sides, we'll get our 28. We'll divide by that 6 and we'll reduce, and you get the same answer either way. You do. It's up to you what you do. This is number 3. You don't have to move your x's left. You can move your x's right. You can move this over here. If you jump equality, you change your sign. Some kids never catch on to that. And if you move your x's to the right, I guess by and large you move your numbers to the left. So whatever you want to do. So there's that line. 9 and 17 should make 26. And 9 and 5 should make 14. Now, some kids just divide by the wrong thing, but you want to isolate the x. We're going to divide by the 14. So we get 26 over 14, which I noticed that both of those are even. They're both divisible by 2. That'll reduce down to 13 sevenths. All right, number 4. Kind of like the last one. I would not distribute because 2/3 of 5, that's 10 thirds. You're just making it ugly. What I would do is I would counteract this division operation through multiplication. And the 3's cancel on the left. So now I have 2 times x plus 5 equals 24. And if I wanted, I could divide the 2 out. X plus 5 is 12. And that gives me x is 7 after I subtract my 5. Now, this can be done a different way too. You could invoke the distributive property. You're still going to get the same thing, because now you're going to subtract 10, and 2x is 14. You're going to divide by 2, and x is still 7. You just got to kind of pick your poison. Number 5 is the new one on here. It's a big deal that a kid be able to solve for a variable, be able to rewrite equations. State of Tennessee, less than 20% of all students could solve something like this. I don't know what the numbers were on Dresden last year, but it was at least 50%. Which, still kind of bad, but way better than average. Anyways, my gut, and I listened to it, says to distribute that 3. And I distribute 3 because I can't divide these numbers by 4. At least not nicely. 3 times 2x is 6x, and 3 times negative 2y is negative 6y. And this is a solve for y. So I'm kind of thinking isolate y. I had to do the distributive property to see how much y was actually on the left. And now that that's done, I can put y's on one side and I can put everything else on the other. So I'm going to move that positive 4 to the left, and you cannot combine 6x and negative 4. And I'm going to move that positive 6y to the right because of the outcome. The outcome is I now have 10 y's on the right. And the last thing to do is to divide by 10. Divide every single piece by 10. And then reduce. So 6 over 10 is 3/5. And 4 over 10 is 2/5. And that would be your y value. That is solved for y. There were several kids who missed the 5, 6, and 7 last time. That's kind of sad. You can do better than that. I don't know what the problem was. 3x times 4x is 12x to the second. X times x is x squared. 3x times negative 2 is minus 6x. It's not a hard problem. 6 and 7 are specifically that double distributive property. So I'm going to distribute the x to both terms in the second set. And that'll give me x squared plus 7x. And I'm just going to pretend it's not there anymore. Now I'm going to distribute the negative 2 to both pieces of the second set of the second parentheses. So minus 2x minus 14. And when I combine like terms, 7 minus 2 is 5. And there's that. It's not a hard thing. 7's the same way, except the numbers are bigger. 5 times 3 would be 15. X times x is x squared. 5 times 8 is 40. Don't forget the x. And now you're done with it. Once it goes to both pieces in the second set, you move on to the next number. Negative 3 times 3, take away 9x. Negative 3 times 8, minus 24. And when we combine the like terms in the middle, 15x squared plus 31x minus 24. Take a small smoke break. Be right back. And I'm back. This is function notation. And it did not go as well as I'd hoped. I'd say probably 2 and 3 if you got it. And this is a skill that everybody should get it. If frickin' SpongeBob was in my room, SpongeBob